Hello friends. Welcome to my YouTube channel. Now we will continue SSC JEE 2011 Electrical Solutions. The question on the screen is, in suspension type insulators, the potential drop is maximum across the lowest disk, maximum across the topmost disk, maximum across the disk at midpoint of the string, and uniformly distributed across the string. So this is the string insulator here, which is hanging in vertical manner, and here we have the power conductor here. So this is power conductor which is hanged by these three insulators, and this is the ground pin. So ground or ground point, you can say. So if you are looking from bottom here, so this is the voltage across, this is the lowest disk, and this one is the highest, or I can say topmost, or topmost disk when you're looking from here. Okay, so this is the disk which is having more voltage stress or potential stress, you can say, in the string of these three insulators here. So the maximum across the lowermost disk. So lowermost disk is the answer here. So this is the correct answer. That is the maximum voltage across the lowest disk. Next question here is, of the following water turbines, which is not a reaction turbine? So in the given following turbine, the Pelton wheel is a non-reaction turbine. That means, what is a reaction turbine? Suppose if the fluid is flowing in particular direction, the turbine is rotates in opposite direction, means it's a reaction turbine. But here, if you observe here in this Pelton wheel, if the water is or fluid is flowing in this direction, the wheel automatically rotates in the same direction as that of the fluid. That means there is a Pelton wheel is a right answer. The next question here is, if the speed of universal motor in AC operation is NAC and in DC operation is NDC, and here I is the current, V is the supply voltage, R is the resistance, X is the reactance, cos phi is the power factor, then the speed ratio is. So universal motor means it's a series motor. So series motor like this. Okay, now it is operating on DC supply as well as AC supply. So for example, say for DC supply, what is the general formula we can write? So EDC is equal to V minus I into R. Okay, and suppose if you are operating an AC supply, impedance will come into picture. So EAC is equal to V minus I into R plus J into X. So this is the AC supply. Now generally we know in AC system, so cos phi is nothing but power factor, which is a ratio of resistance to impedance. Here we can write R by Z here. Now generally E is proportional to speed in any machine. Based on this relationship, what you can write is, from this equation 1 and 2 and from 3, what you can write is EDC divided by EAC is equal to NDC divided by NAC, which is equal to V minus I into R divided by V minus I into R plus JX here. By substituting, so R is nothing but Z into cos phi in the above equation, and we can found that N AC by N DC as, so cos phi minus I into R divided by V divided by cos phi of 1 minus I into R divided by V. So this is the final conclusion that we get. So none of the answers matches this answer. So that for this problem, the answer is not available. Next question. Sheaths are used in underground cables. 2 options are provided proper insulation, provide mechanical strength, provide the cable from moisture, none of the above. So here you can see there is a underground cable here. Here we have conductor and conductor screen here, and insulation is provided here, and insulation screen, and here we are using the metallic sheath. This is a metallic sheet here. So what is the purpose of this metallic sheet here? This metallic sheet is going to protect the cable. So this is a cable, this part from entering of moisture. So cable from moisture. Okay, so this metallic sheet is going to protect the conductors from entering the moisture into the cable insulation. That is a property here. Next question on the screen is, if the frequency of a transmission system is changed from 50 Hz to 100 Hz, the string efficiency will be. The string efficiency is proportional to total voltage across the string. Okay, total voltage across the string. Now what will happening here is, so V voltage across the capacitor string. So VC is equal to IC into XC. So XC is nothing but 1 by 2 pi F into C. So as frequency increases, so F increases means what will happen? Xc automatically decreases. As Xc decreases, what about the Vc? Decreases. As the Vc decreases, what about the string efficiency? Decreases. So string efficiency will decreases is the answer. Thank you friends. Thanks for watching my video. We'll continue the remaining problems in our next session. Have a nice day.